Hi guys, as we have covered all the basics of sinusoidal functions, now we are ready to do the application problem of sinusoidal function. So let's take an example for it. Let's read the question. Megan is sitting in rocking chair. The distance dt between the wall and the rear of the chair varies sinusoidally with time t. At t equal to 1 second, the chair is closer to the wall, and d at 1 means distance at 1 second is 18 centimeters from the wall. At t equal to 1.75 seconds, the chair is farthest from the wall, and that is with a distance of 34 centimeters. Okay, whenever it's a word problem given, always remember the words farthest, highest, they all represent the max points. And the words like closer, nearer, nearest, they all represent a min point. So we see that a min point is at 1, and what's the value of the min point? 18. And a max point is at 1.75, and what's the value of it is 34. So let's use this information to turn it into a graph first. Let's say this is my dt axis, means distance axis, and this is my time axis. I need my time to be, let's say this is 1, this is 2 seconds. Distance at 1 is 18, so let me mark this as 18, and distance at 1.75 seconds is 34, so let's mark this as 34. This is the minimum point, and let's say 1.75 is somewhat here, so this would be the max point. And how would the graph look like is, when I connect the min and the max point, this is how my graph is going to look like. I don't know how the graph is going to be before it or after it, but I know this is my min point and I know this is my max point. So definitely before this the graph is going to go like this, and after this the graph is going to go down like this. Now let's read the question. What is the period of this function? Period means time period, and we know time period is the time taken to complete one cycle, and one cycle is always the time between two maxes or two mins. In this scenario, we're not given two maxes or two mins, but we have learned in one of the video lessons that going from min to max is a half time period. So that means my min starts at 1 and my max is at 1.75. So the distance between 1 to 1.75 is 0.75, and this 0.75 is nothing but my half time period. So half time period is equal to 0.75. However, I'm not looking for half time period. I'm looking for full time period. So full time period will be 0.75 multiplied by 2, which is 1.5. In this case, the unit is seconds because your time is in seconds. Let's read the next part of the problem. It's the same problem, graph is already drawn. How far is the chair from the wall when no one is rocking on it? So you see they are saying that when the chair is rocking means it's going back and forth, then coming back, then going forth, coming back. So this is how it's gonna be going over into a cyclical motion. So when it is not rocking, that means it's still at this point. So this point is nothing but your equation of axes, or the central point of the max and the min. So how far is the chair from the wall when no one is rocking on it is your equation of axes distance. And how do we find that out? As we know, the max is 34 and we know the min is 18. Equation of axis is represented as C, and that's going to be 34 plus 18 because it's max plus min divided by 2. When we put this on the calculator, we get 52 over 2, which is equal to 26 centimeters. Let's go to the next part of the problem. Next part wants us to find out if Megan rocks back and forth 40 times, means if this cycle goes on for 40 times, what is the domain of the function? We know domain comes from the x-axis value, and x-axis value is time. So my domain will be written as time belongs to any real number where time has a min value and time has a max value. Now we are looking for what is the min value and what is the max value. Now remember, when she rocks one time, her time period was 1.5 seconds. And if she rocks 40 times. Time period is going to be 1.5 times 40. That is going to be 60 seconds. So the minimum value for your domain is 0 and the maximum value for your domain is 60. Next part of the problem wants you to find out what is the range of the function. Because range represents the y value, and in this scenario, your y is a distance. The chair goes from minimum distance of 18 to maximum distance of 34. And the cycle, if continues, would keep on going like this. So your range means your y value, the minimum limit is 18 and the maximum limit is 34. Therefore, our range is dt belongs to any real number where the minimum distance is 18 and the maximum distance is 34. Let's go to the next problem. The next problem wants you to find out the amplitude of the function and what does it represent in this situation. So as we know, amplitude is max minus min divided by 2. The max value is 34 and the min value is 18. We put this on the calculator and we get 16 divided by 2, which is 8. So the A value is 8. That is the amplitude. When they ask you, what does this represent in this situation? So we see that amplitude is the distance from the midpoint to the max point or from the midpoint to the min point. So that is the maximum distance that the chair can rock by. So in this scenario, amplitude is the distance through which the chair can rock. That's the final part of this problem. What is the equation of sinusoidal function? Now to write down the equation of a sinusoidal function, we need to write down the general equation of your transformed sine or cosine function. It could be either sine or cosine depending upon what do you want to take your start point as. Let's say I want to take my start point as this and this is my minimum point, and the minimum start point is seen with a cosine with a negative a. So this would represent our general equation. The amplitude that we found out in the previous part was 6. So I'm going to put an a as 6. K value we have not found out, but we know the time period is 1.5. So K is 360 divided by 1.5. That would give us 240. So K is 240. X minus D is the phase shift. So if I'm taking this as the start point, everything from the y-axis to this point is my phase shift, and that value is 1. I'm going to put in D as 1. And C is the equation of axes, which lies right in the middle, and that is 26. So this represents my equation. Final part, what is the distance between the wall and the chair at time t equal to 8 seconds? As we know, x is nothing but t and y is nothing but the distance with respect to t. So if we want to find out what is the distance, all we have to do is just sub in this 8 as t in the equation. So I'm gonna solve for d of 8 and I'm gonna put in t as 8 minus 1 plus 26. You can put it all together on the calculator or you can solve it step by step. It's up to you. Make sure you have to follow BEDMAS while solving this. So we multiply this first. This gives us 1680. Then we're not supposed to add this. We have to find out cos of 1680 and that gives us negative 0.73. You just have to put cos 1680 on the calculator. Now we're not supposed to add it again because this is a product, so we have to multiply this with negative 6 first. And we get 4.38 plus 26. This gives us 30.38. So that is the distance of the chair from the wall at 8 seconds. Make sure you don't forget to write on your units. This unit here is centimeters.